Thanks, Don. I would like to kind of jump in here and start off by talking about the kind of the current state of the PowerBuilder client. It's in flux, obviously, because this project is ongoing. But I wanted to touch on kind of where we started and what the application was like, and show a little bit of it to you. The current architecture is UI pattern based. There's little to no inheritance to help us. As a result of that, to help us in the migration effort, we did create an ancestor window so that we could store some instance variables and data store objects and things like that to make it a little easier for us as we move forward. The data windows, by and large, in the application are all external, so very little SQL called directly in the client application. The application essentially just makes calls through a DLL to Nextera in the middle tier, and from what I've seen to date, these calls almost always return numerous arrays by reference, and of course included as part of the call are any parameters and retrieval arguments and so forth. The data windows then are populated based on these arrays that come back, either using a for loop, setting a column value one at a time using set item, or a string is built and then the import string function is called. There's hundreds of global variables that get passed around as windows are open and closed, and the user moves around, and the DLL that interacts with Nextera has roughly 35 external functions, and we think between 350 to 400 remote RPC stubs are present, and we did kind of a sizing effort to you get an idea of how long the effort is going to take, and part of that estimation effort was to document what these calls were, and so a fair amount of things that we need to look at as we continue on in the migration effort. But a big key to this in the client is there's no embedded SQL. All of that happens in the business logic in the middle tier. And in fact, we've tried to kind of keep that as a standard in the API as well. So what is the future PowerBuilder client? Right now it's in flux. We're actively migrating it. The calls to the Nextera middle tier, and replacing that with calls to the API that we've created. Something that we decided on from the get-go was to try to, just based on how their client application is currently set up, to make use wherever possible of the PowerBuilder share data method. This allows us to kind of implement and maintain the MVC pattern that they had. We're able to harvest SQL and business logic from existing code that they have in C. In using share data, we've created data stores that match the results out of the external data windows in the client. And this logic, these select statements in these data stores were then ported to C#, and in both services and controllers. We've made extensive use of the REST client object to make the calls to the API, and this allows us to retrieve data into a data store as basically the return of the service call, and then in some cases, depending again on what we're trying to do, it often just instantaneously populates that external data window because of the share, and it's really fast, and it often means that in some cases, code can be removed because you're no longer calling the set items and things of that nature. So long story short, share data works very well for our purposes and is essentially used as a way to present the data returned from the API back to the user. In some cases, shared data didn't always do what we needed it to. And in cases like that, we made also use of the JSON parser and packager. So this was helpful for ad hoc utility things when maybe you couldn't massage the query in a way to get a value, and so some other method needed to be called to get the last value for a row and in a column and set it. It's nice because you have with a combo platter like this between share data and the JSON parser and packager, you have a lot of flexibility in what you can actually do. And part of the process, we created a developer cookbook, and this was to twofold. One, to help us as we move forward. It was also put together to help the client understand what we were doing. The client actually added a in-house developer to the team, and that person was able to use this and leverage what we had come up with, and kind of hit the ground running and become productive pretty quickly. The next step was really to analyze the PowerBuilder and the middle tier code kind of at the same time. So we would, using the cookbook that I mentioned, we would review logic in Windows, determine what calls are being made in the middle tier, review PowerBuilder Windows for other logic. A lot of these windows would have buttons and other hidden functionality where, in a double-clicked event or something of that nature. So a lot of digging had to be done to kind of uncover what we had to migrate. Usually there was one kind of main external data window, and so we would look at that, kind of get a sense of what columns were there, what data types and so forth, and then build an equivalent for that. Then we would do a little hunting. It was necessary to kind of go through the C files and find the specific Nextera calls and review them. And in some cases, or in a lot of, there would be a C file, but in addition to that, there would be a SQL file, and turns out there's where a lot of their select statements were stored, and I'll show you an example of that in just a minute. We would then, once we find that, we're able to find that SQL statement, that select statement, we would create a new data window using that, and then edit the select as needed. So sometimes we might, to help us with a particular problem, maybe enhance it a little bit by throwing in a subselect to get at something in another table. We would then do some testing by passing arguments to the data window. We added some new libraries to store these objects that were going to get ported to the API. Just made it, in terms of the library list and what it looks like in the PowerBuilder IDE, it just was kind of a logical thing to do. And then we added some architectural items, and it's good to do this from the get-go. And this was simply an additional library that had some user objects kind of dedicated to performing common tasks as they relate to the API. So I'm going to give you a quick demo here, show you the application, and show you what some of that legacy code and the C code looks like, just to give you kind of a frame of reference. So here's the LIS application. Pretty standard looking PowerBuilder application, some menu items, toolbars. there's really only one menu item that it kind of contains all of the that does all the heavy lifting that's part of this application. So there's 5 items off of here, and we refer to these as modules. And it's important kind of just to show you this, because we ended up taking this structure, if you will, and we incorporated it into how we organized the API. But they have, again, 5 areas of functionality: shipping, receiving, tracking, claim processing, and maintenance. Pretty simple interface. This is a very simple window, but not unlike what a lot of the others do, in that the user will interact with the window by entering some data, criteria, doing a retrieve, and getting a list back. And this is actually an external data window here. So the retrieve at this point is actually making a call to Nextera in the middle tier and then populating the external data window. Just something that's a little more involved. In the tracking module, here's a window called Order Events. Again, there's usually a header section where the user can enter some criteria. But notice here there's a little bit more going on, as you've got actually several data windows. And not all of them can be populated with a single retrieve. So in this case, we did use the shared data, but had to enhance it with some other types of calls using the REST client and HTTP client. So that's a little quick overview of what the application looks like, and we'll come back to this in a little bit. Here's actually the PowerBuilder IDE and what the libraries look like. Just to touch on, we've created a web API library to store some objects that are kind of reused, and like a broker object, a data store object. As we add or work on modules and we create data stores that are going to be exported to the API, we created a library for those and put those particular data window objects in there, just to kind of give it a logical structure and grouping. The other key part of this, as you look at a window here in this object, or application rather, is to figure out what's going on in the middle tier currently. So if I switch over to Notepad++, here's an example of a C file relating to the tracking module, and it contains a number of different method calls, and this particular one is called tr select partials. And if I scroll down a little bit, you can see that it's what it's returning, its basic definition in terms of the parameters. Some of these are input parameters, others are output parameters passed back by reference. But this one call is just kind of the tip of the iceberg. So if I scroll down a little bit, you can actually see that based on one of the parameters passed, it will then go out and call other methods in the middle tier. So we have to look at each one of these one by one and figure out what's going on behind them. And in this case, in this instance, this right here is a kind of a placeholder, and it's telling Nextera to go out and find the select statement associated with that. And if I switch over to this SQL file, this is where it's stored. There's kind of a placeholder for that call, the name of that call, and then right underneath that is the actual select statement. So this is the kind of thing that we had to deal with in terms of migrating this application, is looking at all these RPC calls one by one and figuring out where the select statements are, where is the business logic, what is it really doing, and then trying to apply that to the migration effort. Okay. And so these calls that are out in the C world, so to speak, how are they called in PowerBuilder? So let's go back and take a look at PowerBuilder again, and we'll open up. Let's see here. So here's a window. This happens to be a module that we haven't touched yet. So if I open this up, you get a sense of the layout here. A bunch of stuff going on in a header in terms of criteria, an external data window here. Usually there is a retrieve button of some sort, and if we go through this logic a little bit, this is all existing middle tier calls that are being made. At some point, we'll have to dig through this, figure out what's going on, and just kind of from experience, I generally know where to look for this type of thing right now. But what it's doing is calling a window function called wfPopulateData. And if I look at that, this is very common what you'll see in the Nextera version of what they do now. So here's an RPC call called sh retrieve shipment list. It's passing in some input parameters, and you'll notice that there's a ton of stuff coming back, and the vast majority of it are arrays that then need to be accounted for. Here's an example where they're going to do a call a for loop and create a line with all that array data, and then call it import string. Very common thing. And so our job in terms of the migration is to look at that method that gets called in the middle tier, revise it as needed, kind of wire things up in the API, and just call it differently. So that's a little quick and dirty example of what they're currently doing. So to get started, before really anything can be done, we have to create an API. And so we're using Appian SnapDevelop API. It's part of the PowerBuilder 2019 release. When we created the API, we're using the default data store template. There's two others, model store and model mapper. Data store version was just kind of closely in alignment with what we were trying to do, and it works great with the share data approach. We did, kind of after getting it set up and configured, we kind of took a step back and thought about the project organization. How are the folders going to be laid out? How was inheritance going to work in the solution? So that's just something I wanted to touch on, something that's important to think about as you start working on your first API project with SnapDevelop. The startup configuration, this is where this is a class where the service injection takes place, where you can set up utilities such as logging, things like application insights for telemetry, Swagger, kind of providing access to classes that are going to give you properties, settings, things like that you might want to reuse or use anywhere in the application, and of course the database context, and that's what controls which database you're going to connect to. The API is great. SnapDevelop API is great because one of the best things about it is that it's completely wired up with NuGet, and this is a way for you to easily go out and grab frameworks that you can add as a dependency and utilize the code that comes with those frameworks. Just a quick example, I'm using the Crypto Helper package, MailKit, Swagger for unit testing, the XUnit framework, as well as something called mock, which allows you to do mock-ups of unit test without using a database, and that's kind of a work in progress for us right now, but it is something that we've added. So let me give you a quick overview of the solution, what it looks like, how it's laid out. So here we are in Appian SnapDevelop. Over to the right, you can see the Solution Explorer. For those of you that have used Visual Studio, you should be very familiar with that. We have a solution here. I've got two projects that are linked to that solution. One is the API itself, and the other one is the project that's handling our unit test. I'll come back to unit test in a little bit. For now, I just wanted to highlight some of the kind of key things in terms of our solution to migrate this application over to SnapDevelop. We've tried to set up a kind of a folder structure that maps the menu layout of the LIS application, and so by that I mean that in the controllers folder I've created subfolders that represent those modules that we were looking at in the menu list. So claims, maintenance, receiving, shipping, tracking. Their maintenance had a bunch of different like half a dozen or more sub-menu items, so each of those got its own controller. Tracking mainly just has one controller, just because it's the module isn't entirely finished yet, so there likely will be more. The common folder was created because we've got what I call a client controller, which allows you to kind of interact with a broker on the client side, and then a utility controller to do various different things like logging, encryption, perhaps, whatever you need it to do. In addition to that, you have your database context class, your data windows. When you export them from PowerBuilder to SnapDevelop, it basically records or knows what library, workspace, target, and library that they're coming from. And so if I open up this one, this is actually you can see that there's a class that gets created as well as an SRD file. If I expand this one, you'll see that there are even more. So these are a lot of these are the data stores related to this maintenance module that we created and moved over to the API. And so this list will folder list will continue to grow as we migrate more pieces of the application. Extensions are just some classes that allow you to accomplish various tasks such as logging, security. We've got a models folder, but we're not using it at this point in time. Services is broken up between the interface of the service, and once you define an interface, it has a corresponding class that goes with it. So the interface is where you define the methods that are going to be used in that class, and the class itself contains the business logic. So if I just quickly open up this interface for the city service, you can see that it's pretty straightforward, just one method. It inherits from a base object, some string arguments that get passed to it. The definition of it, or rather the implementation of it, is in here. It's called city service. It inherits from the implementation. It gets a handle on the database context. It then creates the method itself, gets cities with the arguments that are being passed. These come from the controller, and here's where the business logic is. In this case, it's pretty simple. It's just creating a data store using a data store that you've imported, doing the database connection, passing the arguments, and returning a data store back to the controller. So in this case, this is pretty simple. If I open up tracking service, you can see that there's more things to look at. Here's an example of where we're actually doing some embedded SQL to get a value out, and sometimes that's necessary. But most often we're just calling data windows, data store objects to get at things. And here's one that's a little more complicated because we're getting some data back, but then we have to do some set items on that, to figure out, to do various calculations for quantities of orders that are being returned. So there's all kinds of different things you can do here. Let me close these down and just give you a quick touch on a couple of other things that are important to know about the interface itself. You can do a build, of course. You can debug an item. So if you open up a service, you can put a breakpoint on that. You can publish that. You can do it one of two ways. If I select that, it can be a file system deploy, which is what I'm doing here, or you can do something what's called web deploy. It's a little more complex, but in terms of setting up, but it's more robust. Mainly it's great if you have deployment on a remote web server. But just because I'm working directly on the machine where IIS is running, it just worked out best for me to have it set up this way. But it could change over time. We'll see. Also, a key thing to know about the solution is the project. You can go to its properties, and in the debug section you can control how the default browser, IIS Express in this instance, how it executes when you do a control F5, which basically is telling it to run the API. I've got it set to start up Swagger immediately, but you could just as easily put in a full URL path to the controller along with the retrieval arguments, and if you launch this, it's just going to call that and you'll get the JSON back. In my case, if I hit control F5, what it's going to do is start up Swagger, which I have running here, and you're going to get the API definition, and you can see here all these different modules and their controllers are defined here. These are all things that we've created to this point. I've got one particular controller method expanded here, and this is what's great about Swagger is you can put in a retrieval argument for a particular method and click execute rather, and if it works, you'll get a response back, and it's nice because it gives you the full URL, which comes in handy at times when you might need to hook up a different controller inside of the client. It gives you a response body back along with the response code, and you can see as I scroll through here, there's rows and rows of data, and this is all getting sent back to the PowerBuilder client as a data store, which you could then manipulate just like you could if it had been created and retrieved within PowerBuilder. Also of note is at the end, so I've got these rows of data, but I've also appended another data store. This is the data packer object that's part of SnapDevelop. It's a great tool. It allows you to combine in multiple data stores, which could have multiple rows or just a single value, which is what this is doing. This gives the developer a lot of flexibility in terms of when you get the response back, you can parse through this and get bits and pieces that you need in order to perform some logic. So it's pretty powerful. So that's a little bit about kind of this setting up the UI, things to think about in terms of organizing it, tools to use, dependencies, packages that you might want. So let me move on here, and we'll move on. Go to the next slide. So at this point, we're kind of coming back to the PowerBuilder client. We've talked about the legacy code that's there, a little bit about the creation of the API, and then what? So at this point, you're really ready to start updating the client itself. So one of the key things is you want to link the external data window and the data store using the share data. Then it's a process of adding code and logic to make the window and its functionality to work the way that you need it to with the API involved. And that's going to mean making REST client or HTTP client calls, and which one you choose depends on the requests that you want back. Either they can be get, post, delete, creates. If you're getting a JSON response back as opposed to a data store, then you can use the JSON parser and packager. And this, again, I think I touched on this earlier, but those two combined with the share data method give you a lot of flexibility and in handling kind of unique pieces of or data sets that you can't get at in one way, across the entire application. So in addition to all of that, of course, there's you need to worry and think about error handling. The LIS application had a lot of built-in error handling. It was part of Nextera, and so we've had to spend some time looking at that and handling it, rewriting it a little bit when it was necessary, and also addressing that in the API as well. So, you might need to add a error handling reference. Logging comes into play there, and using try and catch when appropriate, capturing exceptions in a elegant way and sending that back to the user accordingly. One thing we did was we wanted to be able to run the LIS application in two modes. So because as part of the development team, we're not all that familiar with the application, so we need to be able to run it, put in some parameters, and get the results back as their end users are currently expecting, and then compare that with how it works using the API. So we did that by adding some bypass logic. We have a global variable that's set from the ini files to whether or not they're using the API or Nextera, and depending on that, either call the API or make a call out to Nextera accordingly. Then it's a matter of testing, debugging, adjusting code in both PowerBuilder and the API until you reach the desired outcome. So so I'm back in PowerBuilder. Let me just go ahead and run this. And if I go to the maintenance module and put in city list, this is one of the windows that we have modified to work with the API. So I am from Minneapolis, so if I type in these parameters, click retrieve, will go out and make a call to the API through IIS and return back a result set. Pretty straightforward. You're not necessarily seeing any of the interaction or what's under the hood, so to speak. But that's essentially what we've done, and just again, just opening that up again. In this particular instance, all we did was look at behind the script and the retrieve button, and set up the API call accordingly to replace what was happening with the current middle tier solution. A similar window. I got the wrong one here. Sorry. Control points entry. This was actually the first window that we worked on. So the idea here is a user would enter a value, click retrieve, and it's going to go out and populate these fields from the database. In this case, it's coming from the API. And notice some of these fields have little asterisks next to them. That means that you can double click on them and it's going to open up a window. And here's that city list that we were just looking at. So these are areas where you have to go look in the script and see what's going on, and kind of ultimately replicate what they're doing in Nextera with the API. This particular window has a series of buttons for CRUD operations. So one to delete, one to insert, one to retrieve, and one to update. So I hope that kind of gives you an idea of what the application does in a little more detail, and also kind of the end result. You don't really see much, and there shouldn't be any difference really when you run it via Nextera or from the API. So I'll close the application, and I wanted to talk a little bit about again, I touched on this earlier when we were looking at the API in SnapDevelop. It could be manual, batch script, or automatic using the .NET's publish option. You can use the web deployment or web deploy, which requires some extra installation and a Windows server to implement. Setup. This makes setup a little bit more complicated, but it's better suited to deploying to remote web servers. So it just really depends on your situation. One thing I would recommend is when you start working with IIS is to create a separate application pool for the API. And you can see a screenshot here that I created one called LIS API App Pool. It just gives you the ability to kind of match up your API and or web application with its own application pool. Just a good practice. And if you I do have a link here just to learn more about publishing. Appian actually has a really good document on the various options for that, so something to check out when you have a chance. So the next thing I wanted to talk about is automated testing. And so what we did is we created a separate project as part of the solution, and when you do that in SnapDevelop and or Visual Studio, you can specify that it's going to be a unit test project. And in this particular case, we opted to go with XUnit. Again, then once that separate project was created, we could start writing unit tests. And a key part of that is you want to be able to leverage the business logic that you've already implemented in the main API. So what you do is add the main API as a dependency to your test project. and that allows you to reference services that have already been created, and you can call them in your test. It's good to create a base testing class and inherit it from it that you can handle in that base class. You can, for example, put in your database context, your database connection information, your startup information. It kind of acts like a startup class in a way, and that gives you a good foundation from which to build out your test. Generally speaking, you shouldn't use a live database connection when you write tests. We are in this case, just because it was somewhat unique, and also we're kind of learning as we go. Another option would be to create model classes, and perhaps pair that with Entity Framework that you could use to kind of seed a test database on the fly, and then use that against your test. Again, every situation's different, and so I would encourage you to do a little research on that when the time comes. We did mimic the folder structure of the API project for the sake of consistency, something that our client pointed out when we were demonstrating some of the tests that we'd created. They were initially just kind of lumped all together, and then they made the good point of it'd be nice to have that separated, so that it was more consistent with the other with the main API project. So something to think about, consider. We're in an agile methodology with this project. So one thing that we're doing is, so when we're tasked with working on a window to migrate, it's not considered done until we write unit tests for that. So they wanted essentially 100% code coverage. So it's easy for a developer to think, at least if you're not used to working with unit tests, to think that you're done once you've implemented the logic and tested it and it's all working great. But there is, at least for us in this project, another level, and just something to think about. We're testing primarily services, but you can also test controllers. I have to admit, I'm still controllers are a little bit different in how they're declared in the test environment, so I'm actually still working on some of that. Doing it through the service is a little bit easier, straightforward. And when you create a test, write a test, you should try to set it up in a way that you can check both against valid and invalid data. So let me show you a little bit about what we're doing. So I'm going to close PowerBuilder here and get back to SnapDevelop. And let's take a look at the project for the unit test. And one thing I wanted to point out, as I mentioned this earlier, is in your dependencies, you'll have a project section, and you'll note that I've got the LIS project as a dependency listed here. So this is what provides the connection, so that it knows which methods to call when you do a test. I've got for the controller tests that I'm still working on, that are kind of a work in progress, I've laid out the folders to match what's in the API itself. Same for the services. If I open one of these guys up, you can see that it's inheriting from a unit test base that allows us to reuse the database connection. Here I'm pretty simple. I'm doing a call to get cities, and I'm hard coding, and this can be handled in different ways, but in this case I'm just setting some values, and I'm calling get cities, and I'm comparing the result against a number, it's that number is hard coded to 5, and the result is whatever is returned by the call to get cities, and if they equal, then the test passes. If they don't, then it fails. So pretty rudimentary test, but it does, because in this particular case, since the company is in Houston, I know that they're always going to have some rows for this particular scenario. So that kind of was my thinking in terms of setting up this test. The assert call here in C# is what actually execute the test and determines whether it fails or not. If you go up to the test option in your SnapDevelop UI, there's a test explorer, and this will give you a list of all the tests that are out there. And so in my city service test, here's the one that we're just looking at. You can run a selected test. You can highlight that, let it go, and it will try to do a build and then actually execute the test. And if you get a green check, then it means it passed. So that's a kind of a quick demonstration of what you can do with unit testing. You can run them all if you wanted. It'll take a little bit longer as it goes through, not terribly long, but it will take some time. And of course these tests are growing as we work on different modules of the system. If I expand this one, you can see that I've got close to, looks like 8 or 9 tests here already. So yeah, so the test will grow as time goes by, and very good. XUnit is great, easy to work with, and this provides a lot of kind of a certain amount of comfort level to the client when they know that we're adding this in for them. So that's a little bit about. Next thing I wanted to touch on was source control and continuous integration. We're using Git with Atlassian Bitbucket, so you'll need the client most likely to create repositories in Bitbucket for both PowerBuilder and the API source code. You'll want to be doing commits and pushes of that code as you make changes to those remote repositories, and you'll want to pull changes frequently in a multi-developer environment. Let me stop there, and I'll switch gears over to Jenkins. So here's the Jenkins interface. I have numerous projects here in Jenkins, most of which are test projects. But the two ones of importance for this demonstration are one called LIS API CI for continuous integration, and one for the LIS application itself. So this one is being managed from SnapDevelop, and this one from PowerBuilder. There's an indicator, what the status is of the builds, the last successes, failures, so you get some metrics here, what happens. Just touch on Jenkins. You have the option to add plugins, and I needed this for the API part of this because I wanted to be able to kind of show mainly to show results from unit tests that are run automatically, and there are different ways of doing that, and depending on what test platform you're using, XUnit, NUnit, there are different things you can add here. So again, I don't have time to go into this in detail, but there are, depending on your platform, what you're using, there's tons of stuff out here. All of this generally has some documentation associated with it. but you can add plugins to handle email notifications, to handle how Bitbucket is going to work, how your test results are going to be published and what they look like, and so forth. So there's a fair amount. There's a little bit of a learning curve in terms of getting just beyond a standard freestyle project here. So if I will start with the API because this one is a little more complicated. But it's really cool what you can do. And one of the nice things is you get a graphical interface. It's pretty rudimentary. There are other plugins that will improve on this greatly, from what I understand. But with the pipeline method, you can break it up into stages. So you can pull when a build runs, you can pull the source code, compile it, do a .NET restore on it, and so forth. Then it will go off and try to execute the unit test. Then it will publish those results. Then it will try to deploy the application. And then ultimately it sends some kind of notification. And you have some control over what that is like or how that works. When you view the latest test result, you'll get a list of failed tests. If that's the case, if that's what happened. So this is nice because you can go back and look at the error message and find out what went wrong, and then do whatever is required to resolve that. You get a running history of your builds, some of which are successful, others are unstable, which is what the yellow dot means. The last thing I wanted to touch on here was oops, I got ahead of myself here, is the configure section. So with a pipeline object, you do it a little differently. You create a node, and then you create stages within that node. And so this is defining how we're going to compile and get the source code. So essentially you're telling, all right, this is Git, these are the credentials we're using, and this is my repository for the source code. If that's successful, then it runs the unit test. So it's going to execute PowerShell. It's going to pass in a script that I wrote and do a bunch of things related to that. Then if that's done, it's going to call MS Test, which is a plugin, so it's something you would need to add to Jenkins, and it's going to generate reports, and it also helps generate that graph that we were looking at earlier. Finally, not finally, but the next stage is deploy. This is, again, we're calling PowerShell. I have a different script for that. This one is entitled Publish. And then finally a notification. So this is using an email extension, which is a plugin for Jenkins, and you can control who the recipients are, who the reply to address is, the subject, and so forth. And it will automatically attach a log of the build, regardless of whether it's successful or not. And you can set it up so that it only sends you a email if the build fails. So there's a lot you can do here with Jenkins. And to illustrate that further, what I'll do is I am going to change a unit test. And this is a test that's going to get a good address. And so I'm just going to modify this slightly. And this should cause the test to fail. So if I commit my work, So I'm committing and pushing that. You can kind of see how that works. And what that will do is, since I've committed and pushed changes to Bitbucket, Jenkins is gonna know that something has changed. And so what that's gonna do is it's gonna automatically trigger a build. So if we come back here, let's do a quick refresh. And I may have, this may be set to a timer, which you can do, by the way. So if you only want it to pull every 30 minutes, you can do that, or it could be 5, it could be once a day, so forth. So I'm just going to go ahead and execute a build now. And you can see that Jenkins has kind of launched itself. And again, the pipeline is laid out into 5 stages. It does the source control, the .NET restore, which basically restores all the packages that are associated with your API. So it's now running all of the unit tests. And this will just jug away here for a little bit. I just think it's really cool that it breaks it out this way and gives you a lot of feedback. As a developer, you kind of know what's going on with this build, and it's fairly straightforward to trace down problems when they occur with a build. So this is almost done. It should move on to publish here in just a second. There we go. Publish results is very quick. It's not going to deploy if it finds anything wrong. And it's done. It still thinks it's unstable. There's no the blue dot means that it's good. Red means it failed outright. You can view a console log to see what happens. This will kind of give you a breakdown of what happens in the pipeline. So this is the Bitbucket portion of it. It's doing a .NET restore as part of the PowerShell script that it runs. It's installing all the packages, everything it needs to execute the unit test. Here's a test run. So here it's going out and trying to run all of the tests in the suite. Here's our failure. So it was expecting, did that comparison of that address and failed, and it gives you some stats: 26 passed, 23 failed, and as a result, the build was flagged as unstable. And an email should have been sent out. So this is great for DevOps people, great for developers. If the build breaks, you know right away, and you can go back and figure out what the source of the problem was and resolve it. So where does that leave us? We're kind of at the end here. Findings and lessons learned. I think it's important, as I think back, that it's good practice to create an API architecture layer in the client to encourage reuse and improve scalability. So this means, using an ini file if needed to set globals, creating some user objects to handle reuse of data stores. If you have a data store object that's inherited from the data store class, you can make use of the SQL preview, and so that's helpful when debugging. A broker object that allows you to not only call the REST client but also send things up to the server for some kind of processing. When using share data, it's just to point out legacy code that performed a set item or import string. Sometimes that code can be removed, and that in the long run makes the client application more lean. So not only you're getting, from my experience, you're getting some performance benefit using the API, but you're also kind of improving the code itself. Just a note to file mock frameworks for unit testing. They may not play all that well with some of the proprietary objects that are part of the data store model in SnapDevelop. I'm still working on that. I have yet to figure out how to use mock with a controller unit tests. So that's hopefully I'll know more about that, and in the coming weeks. The initial call to the API, as I kind of mentioned, is a bit slow initially. There's a delay. It's not necessarily slow, but you notice it the first time you try to run the application. You can tell. But after that, subsequent calls were as fast or faster than Nextera. Transitioning, I think, to SnapDevelop is pretty seamless. A lot of concepts that you're used to in PowerBuilder, functionality, the methods that you've always used over the years. These things are there. So transaction management, begin transaction, end transaction, commits, rollbacks, using set items, get item strings, retrieves, updates, all of that terminology is there. So it makes it a great product, I think. Just for someone that hasn't used Visual Studio or .NET that much, it just makes it all that easier, much easier to to kind of help with that learning curve. Jenkins, very powerful. There are lots of other CI tools out there for DevOps. I just found that with some of the things that have been done by others, it was made sense to use Jenkins, and the client in our case preferred that. With all the plugins and the scripting that you can do, it's kind of the sky's the limit. Just be aware that when you're starting a project, you do need to allow for time to do that. And I really like the data packer object in SnapDevelop. It's a great feature because it can be used to return multiple sets of data in one call. So you can have one data store that gets a result set that you need. You can call another data store to do something else, and a third one to do yet a third thing. And you can add all three of those into the packer object and send that back to the client, and then use the parser or packager to split them up and do whatever you need to do. It's a really nice tool. So that is, I think I've run over a little bit, and my apologies, but hopefully that gives you an idea of what we've done with this project, where we're going, lessons, findings, whatnot, things to look out for. Be happy at this point to answer any questions that you might have. So thank you very much.